All right, so think about what we've done. We've talked about the atom, and we've looked and studied the nucleus and realized, hey, the nucleus that really doesn't do much. It's the electrons that do all the work. Okay? And then we spent a whole chapter going into the nucleus and talking about all the different ways that it can do some crazy stuff. That was nuclear chemistry. And then we backed away and looked at chemical bonding and really talked about what happens when electrons share things, what happens when they give away electrons, and how that alters their geometry. Okay? And how they alter the geometry really helps us to define whether something is a solid, a liquid, or a gas. So the last part of chemistry, we're going to look at the differences between solids, liquids, and gases. And this is, of all of chemistry, this is the most practical part. This will help us solve a lot of questions that we might have about the world around us. I think you'll find it very interesting. We'll also have a couple of really fun labs, one of which is this Friday, where we're going to make a big giant molecule, covalent molecule called slime. And I'll explain it to you how it can be thought of as a big giant molecule. So you'll get a chance to come and bring your own and get a baggie full of slime. Every teenager should have the opportunity to make slime at some point in their teenagerness. Yes, teenagehood. Is that better? Teenagerhood? Or something like that. Yes?
Is slime considered a liquid or solid?
Yes. Okay, so if we're going to talk about liquids and solids, here's this guy involved in a recreational activity. He is climbing ice. Now, why would anyone want to do this? I do not know. But he appears to have a Jewish shofar, a ram's horn with him. I don't know why. I don't know whether he wants to get up there and blow the ram's horn, but I think this is some kind of ice pick. This does not, for this Miami boy, this does not seem like fun. Now, I would much, if you're going to recreate with water, I would much rather be doing this kind of recreation. This is my idea of playing with water, liquid water, not solid water, liquid water. Now, the very interesting thing, and for us, it's not that interesting because we always experience it, is that in the midst of this, this guy is breathing in gaseous water. But you know what? This guy is also breathing in and breathing out gaseous water as well. So it is very likely this guy can look down and see water down beneath him. That's all three phases of matter in existence at that particular temperature. That is downright bizarre in chemistry. There are very few chemicals that can exist in all three phases at the same time in a wide variety of temperatures like water can. Now, for us, it's not a big deal because water is such a big part of our planet. But if you were coming from a planet where water was a very rare thing, you would think that this was the strangest thing that you had ever seen. Water is strange, folks. Very strange. Its density as a gas is 2,000 times less than that as a liquid. Water and ice have similar densities, but the solid form is less dense than the water form. That is really, really weird. And that is what's caused the roads to be all messed up. Did you notice? Did you drive around at all with your parents? This was Pothole City back a couple weeks ago. You got to give Oak Ridge credit. They've pretty much fixed most of the potholes in the larger roads and streets. Okay? But still, I-40 is a mess. Why? Because solid is less dense than liquid water. Why is that? You'll see. I'll explain it to you. It takes almost 7 times more energy to convert liquid water to water vapor as it does to convert ice to liquid. Why? I will explain that to you today. This is strange. It should be the opposite way. Solid should be the most dense, then liquid, and then gas should be the least dense. Water and ice are more alike than steam. Why? I'll explain that using a metaphor. How much of the Earth's surface is covered with water? 70%. Coming from most planets, this planet would be considered a water world. Why is water so important? Because we are made up of 60% water. We're ugly bags of mostly water, as the silicon life form referred to us in the Star Trek TNG episode, Silicon Avatar.
Wait, you remember the
Titles? Don't you?
I mean,
How do you distinguish one Star Trek episode from another?
well, see, I like Star Trek. I like the new one.
Don't. Oceans help moderate the Earth's temperature. I know, Natalie, you just want to just die. Okay, here is Seattle. That's Washington. Here's Seattle. Here's Spokane. But on any given day, what? This is Washington. Washington State. Seattle. Spokane. Why is it that Spokane is further south than Seattle, but Spokane is usually much colder than Seattle?
It's not
Yes.
by water, Mr. Moreno.
Folks, any city that's by the water is not going to experience extremes in temperatures like a city that's away from water. Anytime you're on the water, water has a way of moderating the temperatures. Yes. England is a constant 70 and rainy. Cools auto engine and nuclear reactors, provides means of transportation. Okay, so let me have you, here's the notes, study guide for this next sheet. I'll stop you at times. There are 9 attributes.
Maybe it's this one.
All right, here we go. You've seen this already. Let's watch it again. You haven't?
Imagine an Earth without water, life without water. We find it everywhere, in the atmosphere and below our feet. 3/4 of the Earth's surface is covered by this essential liquid. It's a difficult thing to imagine life without water, because our own survival depends on it. In fact, water is vital to the existence of all forms of life on Earth. Water, or H2O, is an unusual compound with amazing properties. These unique properties are what make it so important to life. First of all, water happens to be the only substance on Earth that can be found naturally in all 3 states, as a solid, a liquid, and a gas.
So, here is a substance that can be found on Earth at the same time in all 3 phases: solid, liquid, and gas. Solid, liquid, and gas. Okay, along with that is the fact that water has a very high boiling point. The process of it to going from liquid to gas requires a lot of energy. It has a high boiling point compared to molecules like it. And believe it or not, it has a high freezing point compared to molecules that are like it. A high freezing point compared to molecules that are like it.
It is rare in that it actually expands as a solid, which is why ice can float.
Okay, so its solid phase is less dense than its liquid phase. That is bizarre. its solid phase is less dense than its liquid phase. That is downright bizarre.
Pure water is essentially colorless, odorless, and tasteless. Water has a neutral pH.
Colorless, odorless, and tasteless. That is actually quite unique. You might say, wait a second, I like the taste of Dasani. No, you like the taste of the impurities that they add to Dasani.
Colorless, odorless, and
Tasteless. Most people would say that pure water tastes nasty. Not because it tastes like anything, but because it has no taste. Another one is that it's neutral pH. Its pH is 7. It's neither acidic nor basic.
Which means it is neither acidic nor basic.
Acidic.
Water has been called a universal solvent because it can dissolve many substances.
There are 3 kinds of substances: ionic, polar, and nonpolar. Water is the only one that can take out 2 out of the 3: ionic and polar.
Wherever water goes, either through the atmosphere, the earth, or through our bodies, it takes along valuable chemicals, minerals, and nutrients.
Okay, along with that, water is not a good conductor. Water does not conduct electricity. But when water picks up impurities, it can conduct electricity. So water is a non-conductor, but when it picks up impurities, it is a good conductor. Remember, if the pool was pure water, you could stay in the pool when a lightning storm comes. But then again, with you being in the pool, guess what? The water is no longer pure. You have contaminated the pool, so yeah, you better get out or else you're going to be electrocuted.
This is one reason why water accounts for about 70% of the weight of a cell, which is the building block of life. Water has high specific heat, which means it absorbs a lot of heat before it changes temperature. This is why water makes a great coolant. This is also why oceans, lakes, and water vapor in the atmosphere help to regulate the Earth's temperature.
So water has a high specific
Water
heat.
molecules
That's
are
another one.
sticky. They attract to each other, which is why
Water is sticky. There are 3 words that we can use, 3 phrases that we can use that would all describe its stickiness. That's adhesion, which is its ability to stick to other things; cohesion, which is its ability to stick to itself; and surface tension, or capillary action, which kind of
water
makes all
tends to flow together, fall as raindrops, and bead up on the surface of a leaf. This property is the result of cohesion. To understand cohesion, let's imagine we're recreating a water molecule. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Because of the molecule's arrangement and the electronegativity difference between the hydrogen atoms and the oxygen atom, the molecule becomes polar.
Water is not just polar, it's extremely polar. Water is extremely polar. That's the last one that I can think of. Water is extremely polar.
The oxygen atom has a negative charge, while the hydrogen atoms have a positive charge. Since we all know opposites attract, the oxygen atom will stick to a nearby hydrogen atom. The result is a strong bond. Surface tension is a result of cohesion and is the measure of how difficult it is to break the surface of a liquid. We can observe the high surface tension of water by watching this mosquito step onto its surface, or this insect as it struggles to free itself from a droplet. Surface tension is also what causes a water droplet to take a spherical shape. Water is the most cohesive of all non-metallic liquids. Adhesion is similar to cohesion, but refers to 2 different surfaces or molecules with an attraction to one another. This is why the droplet sticks to this leaf. Along with cohesion, adhesion is responsible for a phenomenon called capillary action. Capillary action is the force that pulls water upward against gravity through a narrow tube. This is an essential property for plants, which rely on capillary action to pull water from their roots up to their leaves.
Okay, so the really mind-boggling thing is 3 or 4 of those attributes had to do with the fact that water was polar. And water is polar because it is tetrahedral. A lot of you guys want to draw water like this, and you're going to be absolutely wrong. Do you realize that if water was like this, it would be non-polar? Therefore, it would have very little adhesion, very little cohesion. It wouldn't be able to dissolve things. It wouldn't be able to even be less dense as a solid. In other words, life could not exist here on earth if water was linear. The only reason why it exists is because water is that shape. All right. Any questions about the uniqueness of water? Then let's talk about the differences between melting and boiling and freezing and whatever. Okay, I'm going to use a metaphor to help you understand. So we're going to start over here with Morgan. Okay, Morgan has a tight rope attached to her waist, and the other end of the rope goes over to Ruthie, which has another rope looped around her waist, and that goes to Mark. Actually, every one of you guys are attached to each other by this tight rope. Okay? You're attached to Alex. So Morgan comes up to me and says, "Hey, Mr. Moreno, I need to be excused to go to the ladies' room. I must excrete." Okay? So, Morgan, you can excrete, but the only way that I will allow you to excrete is if you give me $1, so that will give you permission to stand up and leave the room. Okay? Well, she looks at me and says, "I really need to excrete, and I have no money." So I give her, hold on, 4, 8, 11, 12, 13, 16, 19. I give her $19 and ask her for $1. She gives me $1. I say, "You may now get up and leave." So get up, get up, get up. Okay, she probably gets to about here, and then she feels a tugging at her waist, and she looks back, and Ruthie looks at her sheepishly. She decides to pull some more, and Ruthie falls down. No, don't fall down. Falls down and is now looking at her with this weird look of, "What are you doing?" She pulls some more. Now Ruthie is being dragged on the floor, and Mark is feeling the tug of the rope. Mark goes down. Morgan gets to about here. Mark and Ruthie on the floor before she realizes this is not going to work. Okay? She looks at me and says, "Can you cut me loose?" And I say, "No." So now she has a choice. She can either go back and sit back down and hold the waist that she has inside of her, or she can give the money to Ruth and hope that she spreads the money so that everyone can go. Because you guys are all interconnected. You can sit down. You are all solids. You're all rigidly held in place, and you're connected to each other. In order for you to go excrete, Morgan, you are going to have to follow the musketeer rule, which is all for one and one for all. This might be a good time to be a communist and not a capitalist, folks, because the only way any of you all will ever get a chance to excrete is if what? You all leave, which means then Morgan has to give me $1 and pass the 18 along to Ruthie. Ruthie gives me $1, pass the 17 along to Mark. Mark considers, is there any way that I can keep most of this money? No, there isn't, Mark. Give the money to Elizabeth. Until finally Ryan gets handed $1. He thinks, no, I'm not going to go anywhere. They can just drag me. Which they might, but it might get a little icky being dragged into the bathroom on the floor. Okay, so finally he gives me $1. Now you all are what phase? Liquid. You're still interconnected, but you now have more mobility. Whereas there was no way that you could talk to mortal back there. Now as a liquid, you can come and talk to each other. You can move around. You're more mobile as you're going down the hallway. You are very mobile. Nevertheless, when you're going into the restroom to excrete, it's going to be a little awkward. You might want to turn on the water faucet so that nothing's heard and that kind of stuff. Okay, so you go down to the cafeteria, explore that area as a group, because you can't ever disconnect, but you're free-flowing to a certain extent, but you're still connected to each other. You are liquid. Alright? Finally, you get to the bus loop over there, the entrance where you come in from the buses, and there I am with these giant shears standing by the door. Morgan's tired. She wants to go home, so she comes up to me and says, Mr. Moreno, I'd like to leave. Can I leave now? I go, yes. You give me $1, I will cut you loose. And you can leave. She goes, I don't have any money, and I really want to go. She looks at me with those pretty blue eyes of hers. I have to. You know, she probably has a dad that just gives in every time. Do you have your dad around your little finger? Probably. Okay. I give in. I give her $19. She gives me $1. I cut her loose. She takes off with 18 of my dollars. Bye, Morgan. Everyone's waving goodbye before you realize you're still here stuck with me. So I look at Ruthie, and Ruthie goes, how can you say no to that face? I can't. So I give her $18, fully expecting her to turn around being as sweet as she is, and giving $1 to everyone, including Ryan, but she doesn't. I cut her loose, and she takes off running. She goes, I feel kind of bad about this, and then she takes off. With 17 of my dollars. I have now encountered 2 capitalists. An hour ago they were communists. Now they're capitalists. What happened?
He talked some logic into them.
So I come up to Mark. Surely Mark will be a communist. Mark, here's $17. Spread the wealth. Share with those that have none. I cut him loose. There he goes. Hey, wait for me. Are we going to Chick-fil-A?
Wait, why'd you say yes to Mark?
Alright. Alright, Brian.
So, 18, 17, 16. Marina. Yes. Phoebe.
Yep.
So, how much is this going to cost me?
A lot of money.
Now do you see why it takes 7 times more energy to convert from liquid to gas than it did to convert from solid to liquid? Solid to liquid, what were you guys? Communists. Why were you communists? Because you had no other choice. That's why the people in the Soviet Union were happy being communists. Because they had when they went to election, they had one person to choose from. They didn't have different choices. You can either vote for Vladimir Putin or you could end up in Siberia. Those are your choices. So most people were saying, yes, we're communists. When you guys were interconnected, you had no other choice but to spread the energy until finally all of you guys could become liquid. Given the choice, what were you guys? What did you guys become? What would humans usually typically become? Capitalists. Okay? So, what happens when you heat up ice? Molecules gain enough energy to break the weak bonds that hold them rigidly together and start sliding past each other. That's what you guys did when you left this room. You were able to slide past. You're still interconnected, but you're able to slide past each other. What do we call the temperature at 1 atmosphere? And that's the key. Okay? This is the normal melting point. Normal means at 1 atmosphere. Why is 1 atmosphere important? Because that's the pressure that is typically around most of the world. Now, the higher elevation you go, the less atmospheric pressure you go. There are going to be extremes. When you go up to Pikes Peak, water will not melt at 0. Water will not boil at 100 because the pressure is not at 1 atmosphere. Yes?
Can't you boil water if you remove all the air out of
Yes. Because boiling point is dependent on the air pressure. So when I say normal boiling point from now on, normal boiling point is 100 degrees. But the boiling point of water can change with the change in atmospheric pressure, and I'll show you that. What do we call a graph that illustrates these temperature changes? We call it a heating curve, and we'll pick there up tomorrow.